Hello friends, in today's session we are going to cover next topics in input output in Java. So we will start from how to read and write to a file. Java provides a number of classes and methods that allow you to read and write to files. All files are byte oriented and Java provides methods to read and write bytes from and to a file. But this will wrap to a byte oriented file system stream within a character based object. So what is the byte oriented and what is the character oriented? We will see it later. So first of all, we will see how to read and write to a file. Two of the most often used stream classes are file input stream and file output stream, which create the byte stream linked to a file. To open a file, you simply create an object of one of these classes, specifying the name of the file as an argument to the constructor. So what you have to do, you have to specify the name of file that you want to open, and after that you will create an object of file input stream or file output stream to read and write to a file, and then you will operate on that file object. While both classes support additional overridden constructor, basic constructors are file input stream that will be having string file name and file output stream with string file name. Both will throw the file not found exception. File name specifies the name of the file that you want to open. When you create an input stream, if the file does not exist, then file not found exception is thrown. Then file output stream, if the file cannot be created, then file not found exception is thrown. For example, if you want to write to a file and that file does not exist, then file not found exception will be thrown. And for output stream, if file cannot be created, then file not found exception will be thrown. But for output stream, for writing to a file, if you are a file already existing and you are creating a file with the same name, any pre-existing file will be destroyed and it will be overwritten. Then you when you are done with the file, you have to close it file by using file object dot close method. So what is the syntax of file object dot close? Void close throws input output exception. To read from a file, you can use a version of read that is defined within a file input stream. The one that we will use is shown here, integer read. And what read will do, it will read a single byte from the file and returns the byte as an integer value. Read will return 1 if the file end of file is encountered. So if you are getting 1 as an integer value, then end of file is encountered. The following program uses read to input and display the contents of the text file. So what is the program we will be seeing here? The try catch block that handles two errors that might occur when this program is used: the specified file not being found or the user forgetting to include the name of the file. So why we are using try catch block? If the specified file is not existing, not found, or file name is not specified, in that case that exception will be caught into the catch block. You can use the same approach whenever you use command line arguments. Other input-output exceptions that might occur are simply thrown out of the main method, which is acceptable for this simple example. If you want to handle all input-output exception by yourself when working with the files, you will specify the catch block for each and every time, every type of exception. Okay, like all exceptions, you will specify one by one, and at the last main class of exception you will specify, so that that exception will handle all types of exceptions. Now we will see that example. To use this program, specify the name of file that you want to see. First of all, we will create the file called text.txt, and you will specify it using the command line java show file test.txt. So Java is for running, show file is the file name now of your Java program, and test.txt file, that is a text file you have already created and placed into your program project, and it will be read. Now we will see the show file class. In the main method, file input stream object we have created. File input stream is equal to new file input stream args of 0. So whatever command line argument that you will be specifying, that is test.text, will be your file name and it will be specified to the file input stream. Then file not found exception is thrown. Also array index out of bounds exception is thrown. Now read characters until end of file is encountered. Okay, so how you will know that end of file is encountered? Using -1. I is equal to fin.read. Fin is the object of file and read is a method to read 1 by 1 byte from the file, and it will be stored in integer I. If that is not equal to -1, you will specify that convert that integer to a character and you will display that character, and unless and until it is -1, this loop will iterate. And after you are done with file, you are closing it using fin.close. To write to a file, you can use the write method to defined by file output stream. The simplest form is void write integer byte value throws input output exception. This method writes the byte specified by the byte value to the file. Although byte value is declared as an integer, only the low order 8 bits are returned to a file. So write is a method, it will throw the input output exception, and whatever byte you are specifying in bracket, that will be returned to a file. And it is declared an integer. All 32 bits are not written in the file, only low order 8 bits are returned to the file. If an error occurs during writing, input output exception is thrown. Now we will see the write example. Now in this example we will specify the name of source and destination file. To copy the file called first.txt to a file called second.txt, you have to use the command line argument like Java file name, first.txt, second.txt. So first.txt will be the file in which you are specifying the data to be copied, and in second.txt will be the plain text file without any content, and from first we will read the data and to second we will write the data. Now file input stream object fin, file output stream object fout. Then file input stream object is initiated with args of 0, first argument. Then file not found exception is got. Then fout object, new file output stream args of 1, that is second object. Catch file not found exception E, error opening output file, return. Catch array index out of bounds exception E. Okay, so here file not found exception, also array index out of bound exception is got. Now first of all, what we will do, in the previous example we were only reading and displaying the output to a console. Here you will read 1 by 1 character, storing it into integer, and that integer you are writing to the next file. You can also convert that I to character like in the previous example, so that all the characters will be displayed or returned to the next second file. After done, you are closing this using fin.close and fout.close. The potential input output errors are handled in this program. Unlike some other computer languages, C and C++, which uses error codes to report file errors, Java uses exception handling mechanism. So whatever types of error that will be created, that code will be written in the try block and exception will be caught into catch block. And for using this, file handling is a cleaner, but it also enables Java to easily differentiate end of file condition from the file errors. Okay, but in C++, main input functions return the same value when an error is encountered and when the end of file is reached. But in Java, it is a separate mechanism to find out if the file end of file is encountered. EOF condition is often mapped to the same value as input error. So we cannot differentiate in C++ whether it is an error condition or whether it is the end of file condition. The programmer must include extra program statements to determine which event is actually occurred. But in Java, errors are passed to your program via exceptions. So for exception handling, where separate try catch blocks are given and not the values written by the read mechanism. When read returns 1 minus 1, it means only one thing, end of file has been reached. Okay, so all other types of error are encountered or catched by the exception handling mechanism. So you don't have to worry about any type of exception. Then applet fundamentals. We will see with the applets. Java console based applications. We have seen so far these types of applications consider only one class of Java program. Another is applet. So there are two types of programs we can create. First is applet and another is console based application. That is whatever input we will be viewing onto the console. Applets are small applications that are accessed on the internet server, transported over the internet, automatically installed and run as a part of a web document. So these things we have already seen in chapter 1. After an applet arrives on the client, it has limited access to resources so that it can produce a graphical user interface and run complex computations without introducing the risk of viruses or breaching data integrity. Okay, first of all, it has limited access to resources. No more resources are required. It can produce a graphical user interface GUI by its own. It can run the complex computation, and it is error free, virus free, and data integrity is also avoided. Many of these issues connected with the creation and use of applets are found in later chapters when the applet package is examined and also when Swing is described. The fundamentals connected to the creation of applet are presented here because applets are not structured in the same way as the console-based applications. Applets differ from console-based applications in several key areas. Now we will see the simple applet example. Public class simple applet. It will extend applet. For this, you have to import these two classes, java.awt.star, java.applet.star. There is one main method that you must implement, that is a public void paint graphic G. You will override this method. Then using drawString method, you can draw the text that you want to display onto the applet and the x and y coordinates on which you will display this text, a simple applet. Java begins with two import statements, abstract window toolkit, that is AWT. Abstract interact with user either directly or indirectly through the AWT, not through the console-based input-output classes. The AWT contains support for a window-based graphical user interface. As you might expect, the AWT is quite large and sophisticated, and a complete discussion of it consumes several chapters coming ahead. Okay, so AWT is a separate chapter we will be seeing, and it contains the support for window-based graphical user interface, and it is interactive so that user can interact through the Java application. Java applet. It is simple. Applet makes very limited use of AWT. Okay, only one method. Applets can also use Swing to provide the graphical user interface, but this approach is listed later. There is a separate chapter called Swing coming ahead. The second import statement uses import the applet package, which contains the class applet. Every applet that you create must be a subclass of applet. The next line is the class simple applet extends applet. This class must be declared as public because it will be accessed throughout worldwide by code that is outside of the program. Inside simple applet, paint is declared. This method is defined by the AWT. It is must method. It must be overridden by the applet. Paint is declared paint is called each time that the applet must display its output. This situation can occur for several reasons. Okay, every time paint will display its output. Why? The window in which applet is running can be overwritten by another window and then uncovered. Okay, so applet window has a minimize button like any normal window. Minimize, maximize and close button. If any time, for example, if user is listening a song and that first song is finished and he wants to start a new song, then what it will do? He will minimize the applet window. He will maximize the song window. Then he will start with a new song, and then again it will paint or it will call the applet window. So that time that window should be recovered. Okay, so applet window calls paint method again and again. Every time the applet must display its output. Okay, so first output will be overdone, or first output will be destroyed when user is opening the second window. For that purpose, paint is called each time. Applet window can be minimized and then restored. Paint is also called when the applet begins execution at the first time. Whatever is the cause, whenever applet must redraw its output, paint is called. The paint method has one parameter of type graphics, that is graphics G, we are passing over here. This parameter contains the graphics context, which describes the graphics environment in which the applet is running. This context is used whenever output to the applet is required. Inside the paint is a call to draw string, which is a member of the graphics class. This method outputs a string beginning at the specified x and y coordinates. Draw string is a method to display string x and y are the x and y coordinates. Void draw string message integer x integer y. This is the general form or syntax of the draw string method, and it will return nothing, so that its return type is void. Message is the string to be output beginning at xy. In a Java window, upper left corner is the location 00. So xy, whatever you are giving from left 0 to up 0, x and y will be calculated, and at that particular position your string will be displayed. The call to draw string in applet causes the message a simple applet to be displayed beginning at the location 2020. Notice that the applet does not have a main method. It does not require it. Unlike Java programs, applets do not begin execution at main. Most applets do not even have a main method. Instead, the applet begin execution when the name of its class is passed to the applet viewer or to a network browser. Okay. When applet will begin execution when the name of its class is passed to applet viewer or to a network browser. So there are two methods to run the applet. After you enter the source code of simple applet compiled in the same way that you have been compiling your Java programs previously. So compilation is same for Java console based applications and applet, but the running is different process. There are two ways executing the applet within a Java compatible web browser like Firefox, Mozilla, etc. using applet viewer such as the standard tool applet viewer. Applet viewer executes your applet in a window. It is generally the fastest and easiest way to test your applet whether it is running properly or not. Each of these methods are coming. To execute an applet in a web browser, you need to write a short HTML text file that contains a tag that loads the applet. Okay, for the web browser part, what you have to do, you have to give the HTML tag. After that, you will write the actual applet, or you will include the applet file inside that. Okay, so here is the HTML file that executes the simple applet code. Simple applet width 200, height 60, and applet code is finished. The width and height statements specify the dimensions of the display area used by the applet. The applet contains several other options that are examined more closely later. After you will create this file, you can execute your browser and then load this file, which causes simple applet to be executed. Okay, so you have to open this browser and enter the file location, or you can directly drag and drop the file to the browser and your simple applet will be executed. To execute the simple applet in the applet viewer, what you have to do, you may also execute the HTML file shown earlier. For example, C:applet viewer run app.html. If the preceding file HTML is saved as runapp.html, then the following command line will run simple applet. C:applet viewer run app.html. A more convenient method exists that you can use to speed up testing. The simply include comment at the head of the Java source code that contains the applet tag. Your code is documented with a prototype of the necessary HTML statement, and you can test your compiled applet then merely by starting the applet viewer with your Java source code file. Okay. So what is the more convenient method? You have to include a comment at the head of your Java source code file that contains the applet tag. And after that, your code is also actually documented with a prototype of the necessary HTML statements, and you can test your compiled applet merely by starting the applet viewer with your Java source code file. So what is the example? Applet code, simple applet, width 200, height 60, complete class simple applet extends applet. You can quickly iterate through applet development by using this step. Edit a Java source code file, compile your program, execute the applet viewer specifying the name of your applet source file. Applet viewer will encounter the applet tag within the comment and execute your applet. So this is the output of simple applet. It has minimize, maximize, close button. It is the location 2020. Here we have written the text, a simple applet, and applet status state is written over here, applet started. Applets do not need a main method. Applets must be run under applet viewer or a Java compatible web browser. Under user input output is not accomplished with the Java stream input output classes. Instead, applets use the interface provided by the AWT or Sweep. Now we will see the transient and volatile modifiers. Java defines two interesting type modifiers, transient and volatile. These modifiers are used to handle somewhat specialized situations. When an instance variable is declared as transient and its value need not persist when an object is stored. For example, class T transient integer A will not persist, integer B will persist. Okay, so transient data will not persist and non-transient data will persist. Here, if an object of type T is written to a persistent storage area, contents of A would not be safe, but contents of B will be. The volatile modifier tells the compiler that the variable modified by volatile can be changed unexpectedly by other parts of your program. One of these situations involves multi-threaded programs. Okay. Volatile will tell the compiler that variable modified by volatile can be changed unexpectedly by other parts of your program. This situation we have already seen in multi-threading. In a multi-threaded program, sometimes two or more threads share the same variable. For efficiency considerations, each thread can keep its own private copy of such shared variable. Okay, one variable is shared throughout the threads, and each thread can keep its own private copy of such a shared variable. Okay. The real or master copy of the variable is updated at various times, such as when synchronize method is entered. While this approach is inefficient, in some cases, all that really matters is that the master copy of variable always reflects its current state. Okay. Master copy is a main copy that will always reflect the current state. To ensure this, simply specify the variable as volatile, which tells the compiler that it must always use the master copy of the volatile variable, or at least always keep the private copies up to date with the master copy and vice versa. Okay, so volatile will tell the compiler what it can be changed unexpectedly by other parts of your program. So for our situation, what you will do, it must always use the master copy of the volatile variable, or at least always keep any private copies up to date with the master copy and vice versa. Okay. And also accesses to the master variable must be executed in the precise order in which they are executed on any private copy. Okay. Now we will see instance of operator. Knowing the type of object during runtime is useful. Okay, so which type of object we are calling, that we will be known using the instance of keyword. You might have one thread of execution that generates various types of object, and another thread that processes these objects. In this situation, it might be useful for the processing thread to know the type of each object when it receives it. Another situation in which the knowledge of the object's type at runtime is important involves casting. In Java, Invalid cast causes runtime error. Many invalid cast can be caught at compile time. Okay. Invalid casting will tell you runtime error. Okay. And invalid cast can be caught compile time, but cast involving class hierarchies can produce invalid cast, and that can be detected only at runtime. So how to avoid this? You will be using the instance of operator. A superclass called A can produce two subclasses called B and C. Casting B object into type K or casting C object into type A is always illegal. But casting to B casting a B object into type C or vice versa is not legal. So how you will find it? Using instance of. Because an object of type A can refer to objects of either B or C. How can you know at runtime what type of object is actually being referred to more attempting the cast to type C? It could be object of type A, B or C. If it is an object of type B, a runtime exception will be thrown. And Java provides a runtime operator instance of to answer this question. Instance of operator syntax is object reference instance of type. Here object reference is a reference to an instance of the class and type is a class type. If object reference is a if object reference is of the specified type or can be cast to the specified type, then the instance of operator evaluates to true. Okay. If the casting is always legal, then object type is of the specified type. This object reference is of particular type or class, or it can be cast to that particular class type. Then the instance of will always give you true, otherwise it will return false. Thus, instance of is the means by which your program can obtain runtime time information about the object. Now we will see the instance of class A. It has two variables I and j integer. Then class B, it has also two variables I and j. Class C extends A, it integer k. Class D extends A integer k. Now instance of you have created class A, B, C, D. Four objects are created. If A instance of A is instance of A, B instance of B, B is instance of B, it will be printed like this. A instance of C. If it is true, then it will print A can be cast to C. Then compare types of derived types. A object is equal to D, a reference to D. Then system.out.println object now refers to D. Now OB essence of D means OB can be cast or OB is a type of D. Then it will print OB is an instance of D, and it will print system.out.println. Then OB is equal to C, a reference to C. OB now refers to C. Then OB instance of D, OB can be cast to D, otherwise it cannot be cast to D. Now OB is an instance of A, it will print OB can be cast to A, otherwise it will not cast to A. Now A instance of object, all objects can be cast to object, that is a main class. Now A may be cast to object, B may be, C may be, and D may be cast to object. So we will see the output. A is the instance of A. What was our first object? A. A is the instance of A, B is the instance of B, C is the C, then A is the instance of C. What is the output? Okay. C can be cast to A. Okay. Then if OB is instance of D, it will print no. OB is instance of D. Then OB can be cast to D or OB cannot be cast to D. Okay. OB now refers to D. OB is instance of D. OB now refers to C. Okay. So what is C here? OB now refers to C. OB is instance of D is not printed. OB cannot be cast to D. OB can be cast to A, and all these classes can be cast to object, that is a main class. The instance of operator is not needed by most programs because generally you know the type of object with which you are working. But it can be very useful when you are writing generalized routines that operate on object of a complex class hierarchy. Okay, if there are multiple classes and multiple derived classes, and there is many more complex class structure or class hierarchy, in that case you will use this instance of operator to find out for which object you are referring to. Then strict FP. Relatively new keyword is the strict FP. With the creation of Java 2, that is after Java 2, floating point computation model was relaxed slightly. Specifically, the new model does not require the truncation of certain intermediate values that occur during computation. Okay, floating point computation model was relaxed slightly. New model does not require the truncation of certain intermediate values that occur during computation. By modifying a class or method with a strict FP, you ensure that floating point calculations and truncations take place precisely as they did earlier in earlier versions of Java, like before Java 2. When a class is modified with strict FP, all methods in the class are also modified by the strict FP automatically. Okay, new model, that is a floating point new computation model, is avoided if you are using the strict FP in short. Okay, if you are not using the strict FP keyword, the floating point new relaxed computation model will be used in your programs, because nowadays we are not using Java 1 or Java 2, we are using Java 8, 9, 10 and so on. Now, when a class is modified by strict FP, all the methods are also modified by the strict FP. Now we will see the following fragment tells the Java to use the original floating point model for calculations in all methods defined within a my class. Strict FP class my class. Frankly, most programmers never need you to use strict FP because it affects only very small class of problems. Okay, so this way we have finished with the some topics related to input output in Java. In the next session, I will try to finish all the remaining topics and then we will move to the practical part. So meet you in the next session. Thank you so much.